Alright, so the fourth guideline says separate memory component registered into individual code segments. So in order for me to explain this, I need to talk a little bit about a general, or the basic building blocks of a general synchronous system, and that's basically a sequential system. Okay, so as you can see in here, and you have probably seen it before, this here is a synchronous system because it has this particular register in here. And what you do see on the other side is, generally speaking, a general synchronous system has some sort of register and has some sort of a logic that decides what's the next state should be. And this logic is, generally speaking, it's a combinational logic, and it also has some output logic, and this is also combinational. Sometimes this output logic is as simple as just the status of the register itself. Sometimes it's a little bit more complicated, maybe a bunch of ands between the different bits of that register. Also, something to keep in mind that this output logic might or might not be affected by the external signals, or whatever we call it, the input to the whole system. So this input to the whole system in here, which we call it an external signal, if it changes and there's this red line in here, it will change the output accordingly, regardless of what the state of the system is. And this is basically what we refer to as a more synchronous system, okay, as opposed to a melee system. A melee system doesn't have this red line in here, so the only way that the output would change is actually by the change of the register itself, and that only happens when the clock changes. So we have three components. We have a combinational circuit that decides my next state, what should my next state be, and we have an output logic that is also combinational, and it decides basically what the output should be, and we have some sort of an internal memory or an internal register that tells me or that stores the state of the current system. And of course, because it's a synchronous system, it actually operates using a clock. And you do see that this is very characteristic of a synchronous system, or that you do have some sort of a feedback loop from the output of the system status, which is basically the register, back to the input. This is very characteristic. It might or might not happen, but generally speaking, you will see something like that. Okay, so this is just a general synchronous system. So how does that third separate memory components registered into individual code segment translate here? Well, as it turns out, that it's just telling me code the register, which is a sequential circuit, alone, code the next state logic alone, and code the output logic alone. Okay, so it's telling me that you have to do these three separate modules. You're not going to create them in separate modules, but you're going to create them in different blocks. This is a stylistic guideline, but it will help you avoid certain errors, certain common errors for beginners, especially if you're a beginner in Verilog or System Verilog. Later on, you might be able to combine, for example, the output logic and the state register. For example, let's assume that it's just a simple AND of all the Qs, or basically a reduction AND for whatever is the state of the system or something like that. You can combine them in a single block. But for now, I'm just going to show it to you as a three separate components, and that's what you will see.